Alright, same instructions. What about this? Find the zeros. Remember, the zeros are the x-intercepts, and to find x-intercepts, you make y 0, but in this case, g of x is the same thing as y. So we're gonna have that's gonna be 0, and then I'm just gonna copy the rest of it down. Okay. And then I just use my factoring techniques. What do I have for my factoring techniques? 40x cubed. Well, I can divide by what's in common. In that case, it's 2, but the first term's negative, so I'm going to divide by negative 2x cubed, negative 2x cubed, negative 2x cubed. Whatever I divide by goes on the outside, and you get 2x cubed. I still have my equals 0. I'm just solving this. Okay, this shouldn't be too bad. Hopefully you're used to it by now. And then what does that give me? That gives me x squared, right? Yes. Then it gives me, oh, negative divided by negative is a positive. Just point that out. And then I have negative 1, or negative, what is this? Just x, negative x. And then this one is 40 divided by 2, negative 2. That would be negative 20. And then those cancel out to 1. But I don't need to write the times 1. So I have that. Oh, that's just a normal quadratic. I can use my x problem on that. So what do I have? What do I have? I have negative 20 and negative 1, right? There's a negative 1 there. When there is no coefficient, there's actually a 1. And this one's negative. So there we go. That's just 5 and 4 with a 5 negative. And then I can use my shortcut because there's a 1 coefficient there. So really, I have 0 equals to negative 2x cubed. And then my shortcut, what is my shortcut? Well, I just take this. This is like x minus 5, x plus 4. Oh. And then each piece that involves a variable. Actually, I can kind of factor this out a little bit more. But, well, yeah, I'll show you. This is helpful in my opinion. So I have negative 2x times x times x, triple x. And then I have x minus 5. Really, you don't need to write this out, but I want to show you something. X plus 4. And remember, set each piece involving a variable, set each piece equal to 0. So really, there's one piece. 2, 3, 4, 5. 5 pieces. Look at this. But look, notice that. That's a 3 there. This, negative 2x equals 0. That means x equals 0 if I divide by negative 2. That happens one time. And then I have x equals 0. That's 2 times. X equals 0. That's 3 times. It tells me that already. It tells me that. I'm just showing you. This is an instance of odd multiplicity because it happens 3 times. So this is odd because 3 is odd. Odd multiplicity. Odd multiplicity. And that means I cross my x-intercept. What x-intercept? 0. I cross there. Okay. Great. That's fantastical. Fantastico. Then I have x minus 5 equals 0. That just means x equals 5. And x plus 4, that's this, equals 0. I'm setting each piece equal to 0. And that would be x equals negative 4. And this is also odd multiplicity. This is odd multiplicity. You're thinking like, oh, 5, odd. Yes, that makes sense. Negative 4, oh, that's even. No, odd multiplicity means the number of times it occurs. Multiplicity. So those are my zeros. And I have 0 actually 3 times. So those are my zeros. I have 5 total. Look at this. Look, what? Amazing. Look, that's... It told me that I was going to have 5. And then these are all odd multiplicities, so they all cross at these x-intercepts. So now I can almost sketch the graph, but I need to think about the end behavior first. So step 1, change y to 0. Step 2, factor completely. Step 3, set each piece equal to 0 and find out the multiplicity. Because when you have odd multiplicity, you cross the x-intercepts. When you have even multiplicity, you bounce off of them. And then the last part is to decide the end behavior. So in this, I have end behavior. Let's say that, end behavior. And I'm looking for my end behavior model, like that picture. I don't have to write it in like I did, like x approaches infinity or whatever. But the end behavior model would be, well, I have an odd degree, right? Odd degree with a negative. Remember, odd degree, hopefully you're looking back at your notes if you don't remember, but odd degree either look like a line sloping upwards or a line sloping downwards. And in this case, it's going to be sloping downwards. Something could happen in the middle, but it's going to be sloping downwards because I have a negative lead. And it's odd. If it was even, it might open up or open down. But that's not this. So, end behavior, on the left side, I'm going up towards infinity. On the right side, I'm going down towards negative infinity. So that'll help me with my graph, and I'll show you why. Okay, so decide the end behavior, then plot the x-intercepts. Well, I have 0, 0, 0, and that's just on the x-axis, 0, and then 0, and 0. It's the same point over and over again. So, odd multiplicity, 0. X equals 5, so I'll do 1, 2, 3, 4, 5. That's an odd multiplicity, happens once. And x equals negative 4. 1, 2, 3, 4. That also happens once. Now, on the left side of my graph, I have to be coming from, like, way, something like this, way up there. Right? I'm going to a positive infinity. And on the right side of my graph, I have to go down here. Okay, something like that. So that's my end behavior. And at all of these intercepts, I cross because they all have odd multiplicity. Okay, so if I start here, and I have to cross, okay, and then I have to cross again, okay, and then I have to cross again, and connect up with that. So there you go. There's your curve. So it's very important to get the end behavior, because if you thought you started down here and you could cross and then you get something that looks like that, and that's wrong. So, yeah, those are the steps. Have a good day.